Hello again, this is Mr. Murray, and we're going to do some adding and subtracting of fractions, or what they call rational expressions. So the biggest deal about adding and subtracting fractions is this. You have to have a common denominator. So these have to be the same. And if you can make them the same, or if they are already, then what you do is combine the tops with whatever operation you have. In this case, it's addition. And you combine those two on top of a single unified denominator, what we like to call the lowest common denominator, or LCD. Okay, so we're going to work through some of these examples. Let's start with the first one, which is very easy because it already has a lowest common denominator of 2x squared. So I don't have to change anything. So I'll keep that the same, put it on the bottom. But now I'll operate on the top. So I have x squared minus 5, and I want to add that to 5 minus 4x. So what do? Combine like terms. So I have x squared, the 5's cancel, and I have a negative 4x, all on top of 2x squared. Now that wasn't really that hard. The thing is, now we have to reduce our answer to lowest terms, because at this point in your classwork, you know that you don't leave fractions, without reducing them. So to reduce fractions, or rational expressions, we factor. So what can I do to the top? This looks like GCF. So I'll take out an x, like so. And then on the bottom, I have 2x squared, which is, well, 2x squared. Nothing going on there. However, I can now cancel this x and one of the x's at the bottom, because there's 2 there, right? It's x squared, which is sort of like saying x times x. So one of them can cancel with this guy. So my final answer is really x minus 4 over 2x. And no, you can't cancel those x's because these guys up top are married. Remember that. This is the final answer. Okay, let's try another one. So this example, again, same. This one's not meant to be any harder. However, most of your adding and subtracting of rational expressions is going to involve this minus sign. And you're going to have to remember and be really careful that you distribute it across the top. So this is what I mean. Our LCD is y squared minus 9. Both fractions have that in their denominator, so we don't have to do anything. So then we said we would combine the top using the operation that we were given. Well, that was subtraction in this case, right? So let me write it like this. Over this beautiful denominator, y squared minus 9. So I wanted to give you this example to show you how important it was to remember to distribute this negative. So we're going to rewrite this as follows. Minus y minus 15. Now we can combine like terms. And when I do, I've got 6y up top. Negative 3 minus 15 is negative 18. Putting that on top of y squared minus 9. Okay, so that's it. Now, again, professionals, let's simplify this to lowest terms. How do you do that? You use factoring. So I'm thinking the top is GCF, right? So that would be a 6. I could take a 6 out, y minus 3. And the bottom is screaming, hey, I'm dots, I'm over here, so let's take care of that. Y plus 3, y minus 3. Look what we can do. Y minus 3's cancel. Final answer, 6 over y plus 3. Beautiful. Okay, next example. Opposite factors. It's a common theme in this unit. Opposite factors. If you remember what opposite factors are, for example, using these guys, if you had 4 minus y on top of y minus 4, we would say that we could cancel those and replace them with negative 1. So when I look at these two denominators, I realize that they're really not the same, and they have to be in order for me to operate with fractions. You have to have a common denominator. Okay, so with the trick of video recording, I just wanted to point out that I did change this to be addition, and it should be that way on your worksheet. Okay, so now what we're going to want to do is make these denominators the same, but since we know that they're opposite factors, here's what you do. Change this operation from whatever it is to the other guy. So if it's plus, I'm going to say we're now subtracting. And then change the denominator to what you need it to be. In this case, I need it to be 4 minus y. And it's as simple as that. If you want to know what's really going on behind the scenes, I'm multiplying top and bottom by negative 1. And by doing that, this is the result. The operation changes and the bottom looks the way we want it. So if you can just remember that, you'll be fine. So let's rewrite this now. I have y squared over 4 minus y, subtract 16 over 4 minus y. So now you would agree that the denominators are the same. So let's combine the tops over one common denominator. Y squared minus 16 over 4 minus y. Okay, that's the answer, but we will reduce to lowest terms. That's what we do. So to do that, let's GCF or dots or AM, however you can factor. In this case, it looks like dots on top, y plus 4, y minus 4. What do we have on the bottom? Nothing. It's 4 minus y. Okay, so now I've factored. I look to reduce and cancel any matches. Well, here we go again. More opposites, right? If we look here, these two, I would love to cancel. And I can, but I have to be really careful because they are opposites. So I want to put a negative 1. So my final answer would be a few different ways. Maybe it's this. Negative y plus 4. Now, this one does not have common denominators yet. So we have to figure out what the common denominator would be. In this case, I would say my lowest common denominator would be 3y, because it's the term that both of my denominators can go into. For example, 3y can go into 3y once. Y can go into 3y 3 times. So it's a common factor to both of them, and it's the smallest one I can find. So that's why they call it the lowest common denominator. Now we have to do some cleaning up here though. They certainly don't have 3 y's. This one needs to be changed. So how do I make this y into 3y? I would multiply top and bottom of that fraction by 3. And that will take care of it. So what we'll have now is 4y plus 3 over 3y, subtract, distribute right there, 3y plus 6 over 3y. Okay, let's combine and let's not forget about this. Very important. 4y plus 3. Let's distribute this negative. Minus 3y minus 6. Combining like terms, 4y minus 3y is 1y. 3 minus 6 is negative 3. This is your final answer. And please, you cannot cancel this 3. You cannot cancel these y's. It's a binomial on top. The only way you can cancel is if you can cancel equally amongst both terms, which we cannot. So that's your final answer. And the last one. On this one I said it's not just a 5 that's missing, because what I see often is that students love to do this. They just multiply top and bottom by plus 5 because they think, hey, my lowest common denominator must be x plus 5, and this guy just needs a plus 5 next to it. All right, so that's not the case. It's not just a 5. The lowest common denominator in this example is actually these two terms pushed together. When in doubt, multiply it out. So the LCD is just x times x plus 5. And if you think about it that way, and you look at what each fraction needs so that the denominators match, you would recognize now that this fraction is missing the x. And this fraction is missing the x plus 5. I hope you can see that that's a huge difference. So now we have some multiplying to do, and then we can get to the subtraction. So let's work that out. So up top I'm going to have 6x minus 3x plus 15 all over our common denominator, which was x times x plus 5. Let's distribute this negative and combine like terms. So that's going to be 6x minus 3x and a negative 15 all over x plus 5. Okay, so now I want to simplify this answer. Now what's tempting is the x plus 5 on the bottom, and when I look at the top, I know my GCF is a 3, so I'd like to pull it out of the top term so it looks like this now. But that doesn't exactly match the x plus 5. So why don't I GCF a negative 3 out of the numerator? And that would leave me with x plus 5 as the factor. That looks much nicer. Because now look, I can now cancel the x plus 5s. So your final answer is negative 3 over x. Perfect. Cool. Okay, good luck on the worksheet tomorrow, and I'll see you soon. Bye.